Okay, so we all know that your x-intercept is in most basic terms where your function crosses or your relation crosses the x-axis, right? That's our x-intercept, okay? Now, in terms of definition, your x-intercept is when your function equals 0. At f of x equals 0, that means that you're looking for the x-intercept, right? That's what this means. So you're saying x comma 0 is what I have, okay? Your y-intercept, in the most basic term, your y-intercept is where your function crossed the y-axis, right? Now, when you're saying it, it's saying that if your x equals 0, that means your y has to be one on the y-axis, right? You're on the y-axis. So if x equals 0, that's telling you automatically that this is on the y-axis. This is my intercept. So you're looking for when x is equal to 0 and y is its own value. Okay, we're going to talk about how to find it graphically and how to find it algebraically. We're going to review graphically. So hopefully that's review. And we're not like, oh, where'd you get those magic numbers from, right? So if we're looking at our graph here, and I ask you to identify where our x-intercepts are. So I'm saying, okay, where are our x-intercepts? You're going to tell me -3. Where else? 1 and 4. So we have our x-intercepts are at x equals -3, at x equals 1, and at x equals 4, correct? And where does our y-intercept lie?
Also -3. That's it.
And our y-intercept lies at. Okay. So because it's a dependent, we either have to write it as an ordered pair or you write it as at x equals. Yep. So we write 0 is just right 0 -3. Because it needs an x in order to be written. X can come on by itself. However, our y needs a little boost. All right, so we're good graphically, right? Now we're going to talk about it algebraically. So algebraically, when you are looking for your x-intercepts, that's where your skills come in for factoring and all of that fun stuff, right? But before, it's always your y-intercept is going to be the easiest thing you can find from a function. So when we look for our y-intercept, that means we're letting x equal 0. Everywhere that there's an x, we plug in a 0. So what does that lead to? We now have 0 cubed minus 3 times 0 squared minus 4 times 0 plus 12. So where is our y-intercept? At 12, because what happens to all these zeros? They become Casper, right? So when you're looking for your y-intercept, that means your x has to equal 0, right? When we're looking for y-intercept, that means that x equals 0. If it's asking for y-intercept, no matter what, you're plugging in x equals 0. So our y-intercept is at 0, 12. Y-intercept, easy peasy, right? Yes?
Why did you just take the last number?
Because everything else became zeros. All zeros. Okay? Now when we're looking for our x-intercept, your x-intercept means that your y equals 0, which means now that your function equals 0. So it becomes 0 equals x cubed minus 3x squared minus 4x plus 12. And that is not as a straightforward solving situation. Okay? Does anyone remember how to solve this?
The x by itself.
You can't.
Oh, you have to do the thing. I forgot
You have to add
A little bit. Grouping.
Yeah.
We have to group. We have to factor by grouping. So I would group them and factor. So we have to group and factor in order to get our x's by themselves. So when my first group, what is the greatest common factor between x cubed and 3x squared? It's just x squared, right? What is the greatest common factor between -4x and 12? And we're going to take out a -4 because the leading term is negative. Is this ringing any bells?
Yes.
Okay. So now when I factor that out, I'm left with x squared times x minus 3 minus 4 times x minus 3. So we grouped, found our greatest common factors, and then we wrote it in factored form. Now we ask ourselves, yes. So from step 2, when you're factoring out, that means you're dividing each term by this. So x cubed divided by x squared is x. 3x squared divided by x squared is 3. When you factor something out, it doesn't disappear. It's just been kicked out the house. Okay. Same here. Our GCF was -4. -4x divided by -4 is 1x. Okay. Huh? It did. It's okay though. That's what my job is. Okay. Now you're going to identify what is your common binomial. What is our common binomial? X minus 3. And when we take out x minus 3, what are we left with? X squared minus 4. Okay. Now that you have your smaller factors, step 5 is to set each factor equal to 0. Yes. You didn't cancel out, you factored them out. So I factored them out because I moved them to the outside. Yes. I crossed them out. Okay. So what makes this true? +3. So we have an x-intercept at x equals 3. What makes this true? And
0.
2 and -2, right? So this can be made true by x equals 2, but it also can be made true by x equals -2. Because a negative times a negative makes a positive. And so I would still end up with +4. Yes. All right. How we feel?
I want to go home this hard.
I know, we can't though. All right. Is it really?
Being serious.
Oh,
How much
no.
time is there?
All right. So that's how we do intercepts. What are our questions, comments, concerns? It should feel like a little bit of a review. It's supposed to be review. All right. So we're gonna move on from intercepts. I'm moving on. I'm stopping. I'm going.